All right, so acid base. It's all about the base. So pH plus or minus 0.02. PCO2 40 plus or minus 2. The PO2 we're going to put at least 70. Okay, but we're not going to talk about that for now. And then the bicarb is 24 plus or minus 2. Okay? So, the way that this works is very simple. For every delta of 1 mm of CO2, there will be a delta change in pH, of course the opposite way, of 0.008. If you like to be exact, we'll do that. If not, it's the same thing as saying a delta of 10 is a delta of 0.08. PCO2 is an acid, so if it goes up, the pH drops. If it goes down, the pH goes up. Okay? This is your base. Now, if you understand the next sentence I'm going to give you, you will never forget it. I learned this system when I was a medical student, and I never had to change it. So, if you forget about everything but the CO2. CO2 equals ventilation. Bicarb equals renal or metabolic. So ventilation is respiratory. This is fast. This is slow. 48 to 72 hours, even with good renal function. Okay, follow me so far? So if I take my CO2 and I come up with a predicted pH for the change in CO2, if it matches, it's a respiratory disorder. If it doesn't match, if my pH is higher than my predicted, I have a metabolic alkalosis. If it's lower than I predicted, I have a metabolic acidosis. Simple enough, right? Any questions so far? Okay. If it's within 0.02, it's a pure respiratory, acute, or chronic. Now, this is acute. Chronic, it's multiplied by 0.003 per 1, or 0.03 per 10. And it's a chronic respiratory problem. Okay?
So you after you get the CO2, you're going to predict your pH, and if that number is, can you just repeat that last part? If that number is greater than the predicted.
Once you do your CO2, we just figured out for the ventilatory part of the acid problem. Yeah. If it matches, it's either an acute or chronic respiratory acidosis and or alkalosis, whatever the pH is. The pH always points to the primary disorder.
Whether it's acidosis
or alkalosis, right. And
And
by the way, all we're doing is math. We're not doing medicine yet. Okay? So if you make a mistake, it's your math. All I need you to do is be able to multiply by 8 and by 3. Okay? Not really sophisticated.
So hypothetically, if the predicted pH is, let's say, 7.2, and your actual pH is 7.1, the secondary disorder will be a metabolic alkalosis.
Because all we're doing is figuring out for respiratory. If it matches, it's a pure respiratory. If it's higher or lower, it's metabolic, alkalosis, or acidosis. Okay? Negatives, your BUN, creatinine, your glucose. So if I have your BUN, I have my glucose, my creatinine, my sodium, my potassium. The only thing we use potassium for is if we do the acid-base calculation gap in the urine. Otherwise, potassium is not used. So chloride, your negatives, and bicarb. So sodium minus chloride plus bicarb equals your gap, which is minus 12 with an albumin of 4 grams. Every decrease of 1 gram for 4, you decrease the gap by 3. So if they don't give you the albumin is expected to be 4. If they give you an albumin of 2, the gap is 6. So they're going to give you a guy with a gap of 9. So there is a positive gap acidosis. Okay? Now, glucose divided by 18. BUN divided by 2.8. Sodium times 2 gives me what? My osmolality. Okay? So, and the main character for osmolality is sodium. Too high of sodium, too little water. Too low of sodium, too much water. Okay? If that, my calculated osmolality and my measured osmolality are greater than a gap of 10 to 15, I have an osmolar gap. Once I have an osmolar gap, typically it's accompanied by an acidosis, metabolic, so these are the alcohols, ethanol, most common, ethylene glycol, methanol, these are all poisoning, or moonshine. Now there's isopropyl alcohol. What's that one? Rubbing alcohol, that's what's across the street, the white bottle. This will give you hyperosmolality, no acidemia. So you can just weigh it out. Okay? And then what is the treatment or the antidote for these? Alcohol, or an alcohol or a dehydrogenase inhibitor like fomepizole. Okay? Because it's not the actual alcohol that has the problem that gets you buzzed, but it's the metabolites that give you the problems. So you want to keep it from going to that metabolite. Okay? Any questions so far? So we got osmolality, and I want you to take your bicarb off the SMA7. Okay? Most bicarbs in the blood gas are calculated, they're not measured. So if the blood gas bicarb says A, then you can believe it. If it's a C, it's calculated, it's only made to make the Henderson-Hasselbalch equation look normal. Okay, so what do we have here? We have 140 sodium, 4.7 potassium, 108 chloride, 22 bicarb. Now, numerically, I'm within the normal. If I ate, it's 130 minus 140. They didn't give us an albumin, so it's only a gap of 10, so normal gap. We don't even have an acidemia. Our blood gas is 7.49, PCO2 of 30, and a PO2 of 99. Okay, so 30, my normal is 40, is 10, times 0.008 is, just move it 1 over, so it's 0.08. This is an acid, it went down, so I have to add it to 7.40. So my predicted pH is 7.48. I now compare it to here, and within 0.01, 0.02, it matches, so I have an acute respiratory alkalosis. We good? All right, let's see the next one. All right, if somebody calls you with an elevated PCO2, or even a very low PCO2, the first thing I want you to ask is, what's the pH? If it's anywhere within normal, let's say 7.3 to 7.5, it's chronic. They're compensated. I don't care if it's a PCO2 is 120. If they're now 7.6 or 7.2, that's an acute happening. And you better jump on that one. All right, next problemo. So 140 sodium, 3.5 potassium, 98 chloride, 32 bicarb. I immediately notice that's too high. So already I have a metabolic alkalosis. Okay? They don't give us a BUN or creatinine, so we go straight to a pH of 7.32. PCO2 of 64, and a PO2 of 59. 40, so that's plus 24. It's an acid, so I gotta take it away from, times 0.08. So 32.032, or 0.32, I'm sorry, right?
0.32.
See, once again, I showed you, if I'm gonna stay on it, make it in math.
0.032.
Yeah, that's right, fine. I really make mistakes, just kidding. Well, you know what the first rule that I have is, right?
Right, wrong.
I'm never wrong. Rule number 2 is, when I'm wrong, see number 1, okay? You can laugh, okay? Alright, so it's an acid, so now 7.40, and I can't, it's basically 03, right? So 8 times 32, no, it's actually, okay, here's once again, perfect example, math problem. 32, 16, 19, 0.192. So 0.19, I take it away, I should have 7.21, correct? So I have a respiratory acidosis. And this is my predicted pH. Now I look at what my actual pH is. My actual pH is markedly higher than my predicted pH, so now I have a metabolic alkalosis.
The respiratory acidosis is primary, right?
Yes, why?
Because it has a lower pH.
The pH always points to the primary disorder. So here we have an alkalosis and acidosis. This is an acid, so this is primary, this is secondary.
Down there you added 7.4 plus what?
Minus. Yeah.
The one before, didn't you add?
Plus 24 from 60, that means that it's an acid, okay? Now, what we need now to find out is, there could have been a pre-existing metabolic alkalosis, a pre-existing metabolic acidosis. So we're gonna do what's called a corrected bicarb. Take your actual bicarb, 32, actually no, we don't have to do it here, we only do that in acidosis.
Suarez,
Yeah.
Can you just sum up real quick how to differentiate between primary and secondary?
Primary,
pH
secondary.
points,
Oh,
pH points at the primary disorder.
the pH always points to the primary disorder. So typically you're gonna have an acidosis and an alkalosis. Your point is very well taken. If you have 2 alkaloses and 2 acidoses, I have the math right here. This is how much acid is being caused by the PCO2, and then this is 0.08. Well, I'm sorry, the difference between these two, 7.21, this is 0.11. So who's winning?
Rest.
This one. So the 0.19 is greater than 0.11. So once again, your math wins out. Whichever has a greater number is a primary disorder. But that's only going to help you when both are either alkalotic or both are acidotic. Okay? We good? And what I want you to realize, this potassium is actually a little lower than 3.5. Why? Because we're acidotic. So that actually comes out. So probably it's 3.2, 3.3. So there, you better act upon that real quickly. Any questions? Cut problem. We have a sodium of 135, low hyponatremic, 3.8 potassium, low normal, 92 chloride, hypochloremic, and a very low bicarb, so I already have a metabolic acidosis. I bring them down, that's 4, that's 104, 135. My gap, immediately when I have an acidosis, I wonder if I have a gap. So my gap is 31, big E. So I have a big metabolic acidosis with a gap. That means your classic mud piles. We have to correct the problem, not give bicarb. Most of the time, there's going to be some kind of decreased cardiac output. When we talked about the ethanols, there you will also have an osmolar gap. There is no osmolar gap because number one, they didn't give us the information to figure it out. And with 135, you have 270 anyway. Okay? So pH is 7.08. And the PCO2 is 42. Okay, so 42, 40, it's only a change of 2, which is basically normal. So 0.016, make it 0.02, 7.38 should be my predicted pH. So basically it's actually normal because it's within my error, and then I bring it up here. So a severe metabolic acidosis. If you wanted to, here's a perfect example, you can make, this is also a mild respiratory acidosis, even though it's within our normal limits. But if you have to go one way, that's what it is. Here, your difference is 0.02 to what? To 0.30. So here you have two acidosis, so the metabolic by far is a causative. So we have a primary metabolic acidosis, and I wouldn't even call it a secondary metabolic. I would just call it a primary metabolic acidosis. Now, I'll give you a layup, which I'm going to give you very often. In metabolic acidoses, or when they give you an acidotic pH, if the last two digits of the PCO2 of the pH equals the PCO2, in other words, let's say it's 10, don't go any further, that's just a compensated metabolic acidosis. So remember, we have 8 plus or minus 2, okay? So that's a layup. Now, here we are going to do a corrected bicarb. So our bicarb is 12 equals, our gap is 31. So our normal gap is 12, 31 minus 12 equals what? 19. 19 plus 12 gives us 31. This is what we started as our pre-existing bicarb. Extremely important because if we don't do this corrected bicarb, we don't know where we started. Our normal bicarb should be 24 plus or minus 2, right? So the highest should be is 26. It actually was 31. So it was a pre-existing metabolic alkalosis. If this number were to come out to be less than 22, let's say 20, there would have been a pre-existing metabolic acidosis. It's the only way you can figure it out. Now, a tertiary disorder should not be available in your test because that's a little bit above your pay grade, but still, they may give it to you because this is an extra formula you need to know. Yes, ma'am?
What's the formula? It's the
Your measured bicarb equals your gap minus your normal gap, which is 12. So that gives you really the excess or more. That, when you add it to your actual bicarb, should equal 24 plus or minus 2. If it's more than 27 or higher, pre-existing metabolic alkalosis. Less than 21 or lower, pre-existing metabolic acidosis. But in the books, in the text, they're always going to give you something that's really big. They're not going to be close because they don't want you to make a mistake. Questions? All right, so now somebody's going to come to the board and do a couple of yes. If it matches, it has to be an acute or a chronic respiratory acidosis or alkalosis. So, respiratory acidosis. For every delta of, now, okay, let me just back up a little bit. The CO2 and the bicarb move in the same direction. So they're both going to go this way, or they're both going to go this way. They don't dissimulate because one compensates for the other. So if you know nothing else, all I want you to do is put in the pH, the CO2, and the bicarb. If all the arrows are pointing in the same direction, I have what? A metabolic alkalosis. It's up, not down. Now,
Respiratory acidosis.
not respiratory, metabolic. Once the pH goes the opposite of the bicarb or the CO2, that's when you have a mixed disorder. So at least walk away with that. Now, I gave you a metabolic acidosis. Let's make it 7.30. What should be my CO2? The last two digits. So if you see this, stop. You don't have to do Winter's formula. It's a compensated it's a layup. It's a compensated metabolic acidosis. Okay? The minute you get an acidosis that's metabolic, I want you to do a gap. Non-gap, take it easy. It's not important. We're gonna give you a little bit of bicarb. No emergencies there. Okay? Gap, problem. Low cardiac output, no oxygen being delivered. We have anaerobic glycolysis. A bunch of bad stuff is going on. We need to reverse the problem, not give bicarb. We occasionally give bicarb to get the pH to a level greater than 7.20 because that's where our drugs work. But otherwise, just you can hyperventilate the patient, keep them there. Okay, reverse what's going on. So a respiratory acidosis in acute. So it says if for every 10 delta, and you're going to have a delta of 1 in bicarb. In chronic, this is acute. In chronic, it's going to be 10 to 4. Okay? And a respiratory alkalosis, 10 to 2 and 10 to 4. So everything's the same except for this. Right? Metabolic acidosis. You already know about the testosterone of the pH. If not, Winter's formula. Bicarb times 1.5 plus 8 plus or minus 2 equals your PCO2 plus, in other words, and then use your plus or minus 2, your range. If it's higher than that, you have that has to be a respiratory acidosis. If it's lower, it has to be a respiratory alkalosis. For a metabolic alkalosis, for every increase in bicarb of 1, there's going to be an increase of CO2 of 0.7. Have we done any medicine yet? No. Once we have our answer, now we say, do we need to act upon it? Notice that the one we're going to act upon it most of the time are going to be metabolic acidosis and metabolic alkalosis. Which one is more frequent in the hospital?
Alkalosis.
Right, because you are on diuretics, you're dehydrated, you're pre-renal, so we start reabsorbing sodium bicarb. Now, that's okay as long as we're not retaining CO2. Once we start retaining CO2 because of metabolic alkalosis, that's overcompensation. We give acetazolamide, Diamox, to have the kidney waste bicarb. When it does that, it also wastes a very, this measurement is very scientific, a shitload of potassium, okay? So give some potassium with your Diamox. Do not give Diamox every day. Give Diamox and check your SMA7 for 3 days. And then give it on a daily basis. Now, the beautiful thing about Diamox is it causes a metabolic acidosis, correct? So it works best in an alkalemic environment. But, let's say we forgot to stop the Diamox. What happens? Okay, and then what happens? How acidotic do you get? The beauty of it is it stops working at a certain like 7.26, 7.32. So if it's not an alkalotic environment, it stops working anyway. So even if you screw up, you're not going to kill the patient. Now, you're going to take away the taste buds. Anything carbonated, going to taste terrible. Okay, not wine, since it's not carbonated. Now we have carbonated tea, so that will taste terrible. Okay, so it's still used for high altitude, even though the PD5 is another drug of choice for prophylaxis, but it could ruin somebody's vacation by ruining their taste buds. I'm sorry? PD5 inhibitors, sildenafil, Cialis, Viagra, because now they're very vasopotent vasodilators. In fact, you'll see right now the contraindication of nitrates with them, it's a very predictable, so I will predict for you guys here now that I'm on tape with Samsung, okay, that eventually you're going to see these pills being used for heart disease. Okay? So you kill 2 birds with 1 stone. So So the only advantage of being a man these days, having BPH, is what? 5 milligrams of Cialis a day takes care of your PDE and your BPH at the same time. So once again, 2 birds with 1 stone. If you are going to kill 2 birds with 1 stone, there's a bird here and a bird here. Which one do you kill first? Never the one in the front, always the one in the back. Because if you hit the one in the front, you will scare the one in the back. Knock off the back one first, and then hopefully the front one won't see you, and then you can back off the front one. Okay? Any questions? You want to do a problem? Your sodium is 141. Do your little box. Retake, I just covered it. 141. Potassium is 4.0. Chloride is 100. Bicarbonate is 34. That 34 should jump out to you, and automatically, what do you have already? What type though?
Metabolic.
Okay, so why don't you write that down? Okay, so now your pH is 7.60, confirming your metabolic acidosis. Your PCO2 is 36. Alkalosis, you're correct. I stand corrected, or I say corrected. PO2 is 59. So now do your stuff. Look at her go. Look at that S-car go. Right, 7.43. Right, so we have a mild respiratory alkalosis, right? Why don't you write that down by your predicted pH. Now, what is the 7.43 compared to your actual pH?
It doesn't match, it's high, so it's
Okay,
higher.
so how much higher?
A lot, but,
0.27.
0.27.
Okay, so we have a metabolic alkalosis. Right, but point to the pH. And here's where your question comes in. We have 2 alkaloses.
Yeah.
But now you see that the 0.27 is so much bigger,
Yes.
the metabolic has to be primary, the respiratory is secondary.
See, hold on, you confused me now because
Uh-oh.
yeah, because your predicted pH came out more acidotic than your pH that was given.
So
So wouldn't that be a respiratory
I told you that that's your predicted pH. So that's your new normal. Now you look at your actual pH, the real pH. If it's higher than your predicted, it's a metabolic alkalosis. Because all we've done is do what would have been for ventilation or respiratory only. If it would have been less than 7.43, it would have been a metabolic acidosis.
But it's still like a respiratory acidosis, I think that's the question, right?
It's a
No, it's an alkalosis, it's 36.
But like, I mean like a conference, oh, okay.
Okay? This is,
I get it now.
Right. so this shouldn't really happen that often. Because here the patient's got a big bicarb,
Okay, I don't think
34.
compensation for metabolic alkalosis.
Let me walk you through it. 34 minus 24. So the delta in the bicarb is 10. Okay, that's 0.07, so that's 7. 7 plus 40 gives you 47. That's what your PCO2 should be. It's much lower, so there you just confirmed your respiratory alkalosis. And what we're talking about, if the patient was doing it correctly, chloride responsive metabolic alkalosis. Because you also have what's called a non-chloride responsive metabolic alkalosis, but typically the chloride would be elevated. Same thing, if you check in your urine and you have a low chloride, that's going to respond to normal saline. If you have a high chloride, that is not going to respond to normal saline.
So since here it's low, it will respond to normal saline.
Correct. But if you really wanted to make sure, you're going to give them the saline and they'll respond, or you measure the urine and you see a low chloride for sure. If you're wasting chloride, it's not going to respond to normal saline.